Today's objective is similar to the last two, but it is for cubic. So on Monday, you should have no class, not absent, but no class, right? Tuesday, you should have done Tuesday's warm-up with us. Wednesday, write PSAT. And then on Thursday, today, you should be writing down this objective. Wow, just like I thought. Okay. Do you have the warm-up? Let's get it out of the blue bin over here. Last folder is the warm-up sheets. Every time you're missing one, that's where you get it. Okay. Now, on your warm-up, you were supposed to graph x cubed, right? Right in the back. Hey. So, you go in here, go to graphing calculator. Who should be on time to class has their warm-up on their desk. Let's do it. So, on new document, new graph, and we're graphing x cubed, x caret 3. Okay? So, hopefully you've seen that before, right? Now, I want to know the domain and range. Now, I'm going to sketch this over here. You can do that if you want. Okay, it looks like this. You don't have to, but there it is. Now, domain, does everyone see how it goes to the left forever? And it's going to go to the right forever. Okay, so the domain is negative infinity to positive infinity. And does everyone see how it goes down forever and up forever? So this range is also going to be negative infinity to positive infinity. So this is kind of like when we did 2.1. It's kind of like linear. Domain and range is always going to be infinite every direction. But if you remember 2.2, that one was where we had a range that had a stopping point, okay? Either a minimum or a maximum. So you can write that down, and then I'm going to pass out your 2.3 notes, because today we're doing 2.3. Here we go. So look at your notes sheet, okay? Let's do the notes for cubic, right? So no one has headphones in their ears, right? Right. And we're not going to fall asleep either, right? We'll see. Here we go. Since we already have this on our graphing calculator, right? Hit Control T, and we can get a table so we can graph this thing. Let's go back a couple. So I want us to plot on our notes these points. So -2, -8, -1, -1. Oops, hold on. We want to write down the -3 as well. Okay, sorry. So -3 is -27, -27. Then we had -8, -1, 0, 1, and then 8 and 27. Now, y'all agree 27 is off the graph, so let's use just 5 of these points. Right, -2, -8, put a point there. -1, -1, put a point there. 0, 0, 1, 1, 2, 8. And if you look at your graphing calculator, that's what you want to match. And you can see how it kind of curves right here and then curves up. So let's do that. Comes up, curves, curves up. Just do your best. As long as you have the right points, it should be all right. Now, can we answer the first two blanks? Yes, we can, because we just did it on the warm-up, right? What's the domain? Yes, we did. What's the domain and range? To positive infinity, right? All right, so let's write that down. Negative infinity to positive infinity. Negative infinity to positive infinity. Everyone get that down? Did you? Now, cubics have no max and no min. Like, in the sense of, there's not one max or one min. They do have local. We're going to talk about that on the notes. But there's no ultimate max or no ultimate minimum. It goes forever. Okay? Okay, they may have a inflection point. Okay, I know it kind of says that down here. It does have an inflection point. And then cubic functions may have up to 3 roots or x-intercepts. Okay. So cubic functions go forever, every direction. They might have a local min or max, but they don't have an ultimate min or max. They have an inflection point where they change, the curve changes its direction. By the way, do y'all know where the inflection point is on this graph? Instead of saying vertex like on the quadratic, we say the inflection point is wherever the translation goes, okay? So the inflection point, okay? Do you see how it's curving upward and then it takes a little twist and curves a different direction? That's what an inflection point is, right? You sure? Sleepy. All right, now let's go to the bottom. I'm going to charge it right here. Okay, let's go to the bottom. Now, aren't you glad this is already filled out for you? Last 2 times we had to fill it out ourselves. Now, let me tell you. Listen. We've done this before. It's the exact same as linear. It's the exact same as quadratic. Okay? So this is cubic, right? A is vertical or horizontal? Which one? A has to do with vertically compressing it or stretching it, right? And it can make it flip over the x-axis. What about B? What does B do? Which direction? Yeah, horizontal. It can stretch it or compress it horizontally or flip it over the y-axis. Down here, C and D, shift it left to right, up and down. By the way, C is always a what? You a lie. Okay? Insiders lie. Inside the parentheses is backwards. Meaning, if that's a positive, it's really a negative. If it's a negative, it's really a positive. Right? And then letter D is shifting it up or down. Cool? So. Yeah, so if any of these numbers are, well, sorry, if A or B are 1, ignore it. C and D, it actually matters. Right? Okay. All right, so same notes as 2.1 and 2.2. We're going to apply it to cubic. Flip it over. Let's do 2 examples. Now, I have it up here at the top, and tiny if you still need to see it, but first thing we want to do is take this graph it in our calculators, Control T, and then we can plot those points, right? Let's do that. So I go to my calculator, press on, new document, right? Do not save, graph. -1/2, Control Divide will give me that fraction that I like to see. Go to the right. And then we got parentheses x minus 4, sorry. Wait a minute. Don't be confused. Don't be confused. And then cubed, caret 3. Y'all know where caret is over here on the left side? Caret 3. Then you have to go to the right, so you can go back down, minus 5. All right, took a while, but we got it. Now, you hit graph, and you want to graph that thing, but we want to have good points, right? So we know to get good points, we press Control T, right? Control T for our table. So let's plot as many of these points as we can, starting at, let's see how far we can get. Okay, that's too big. Let's go with 1, 8.5. Can we do that? Nope, too far up. Let's do 2, -1. 2, -1. Whoop. And then let's do 3, -4.5. 2, -1. 3, -4.5. 4, -5. 3, -4.5. And then 5, -5.5. And then 6, -9. Look at your table. 4, -5. 6, -9. 5, -5.5. 6, -9. All right, so inflection point. Everyone look right here. Look. Inflection point is C and D. Now, let's label A, B, C, and D. Is there an A here? Yeah, A is -1/2. Is there a B here? No. There's no second set of parentheses, so B, no B. But there is a C and a D. Now, C and D are the ones that are going to give you your inflection point. Listen, but remember, C is a liar. So when it says -4, okay, so again, instead of -4, it's a lie. We're going to put +4. And -5 is not a liar, so we're going to write -5. Does everyone see 4, -5 is right here at the center of what I was just plotting? That's going to be my inflection point where the curve changes directions. So let's sketch this. Okay, look at your graph. Think that's what I need to sketch that. So it's going to look like this: coming down, turning the other way, coming down. As long as I can see these good points here, make them kind of bold, then you're good. Now, I wouldn't look at this graph for the x-intercept because it looks like it might be 2. But let's go to our graph and press what to get our x-intercepts? Menu 5, 1. Menu 5, 1. Okay, if you go to menu 5, 1 and you start moving it down, you'll get to your x-intercept, which it'll say 0 like that, right? What's the, excuse me. What's the x-intercept here? U. Hey, what's the x-intercept here? 1.85 comma 0. 1.85 comma 0. Say what? Okay, but that's it. It only crosses the x-axis once. So sometimes you have 3, sometimes you might have 2, but sometimes like this you'll only have 1. Okay, but 3 maximum. Y'all paying attention? Please be quiet. Now, domain and range we already said is always what? For this type of function. What? Negative infinity to positive infinity. Negative infinity to positive infinity. Now, transformations. Does everyone see that our A is negative right here? So if I have a negative A, that means it reflects over the x-axis, right? So reflect over x. Does everyone see why that is? Negative A is reflect over x-axis. Okay, next thing. 1/2 is my A value. Is 1/2 bigger than 1 or less than 1? I hope everyone knows that 1/2 is less than 1. So when A is less than 1, that means a vertical compress. Okay, let's write that down. Vertical compress. Okay, and then last but not least, which way does it shift? So if C was -4, which way is that really going to go? Up, down, left, right. What do y'all think? Okay, -4 instead of being left is going to be to the right because C is a liar. So right 5. And then the -5 is vertical. Is it up or down? What do you think? Up or down is -5? Sure? Down 5. Now, let's do number 2. How is number 2 different than number 1? It's all separated, right? There's no cube, there's no third power here, but there are 3 x's. And if there's 3 x's, that means it is to the third power, essentially, okay? So this is a different type of problem. I'm going to show you how to do it, because guess what? It'll be on your assignment. Now, is everyone done with number 1? Okay, number 2. What we want to do is type this into our calculator, right? So, real quick, when you type this in, there's one thing that's going to give you an error, okay? Error. Right here, you need to put a multiplication sign. Go real quick. So, here's how I would actually type it in my calculator. Y equals, and you're not even typing that part in, but it would be -x times, okay? Right there. That's the part that you have to type in. Times x plus 1, x plus 5. Okay? So everyone, let's type this in so you get some practice so you can see what I'm talking about. I'm going to type it in wrong first, just so you can see it. Okay? So I'm going to go to on, new document, don't save, go to graph. Okay. Now, originally it says -x, parentheses. So let's type that. -x, parentheses. We have x plus 1 and x plus 5. If I type it in the exact way I saw it on the paper and I hit enter, it gives me an error. Does everyone see this error? I don't want you to have to see this error. So here's what you got to do. Right there where my cursor is, put a multiplication sign. Don't ask me why, but that will make it work. Okay? If you get an error, make sure you put a multiplication sign between the variable and the parentheses. Okay? So, now you can see it on the board, and you can actually see the x-intercepts right here. 1, 2, 3, 4. Negative 5 is an x-intercept, right? Negative 1 is an x-intercept, and 0 is an x-intercept. So let's plot those on the graph. Negative 5, negative 1, and 0. And then we can actually put that on the x-intercepts down here. Negative 5, comma 0. Negative 1, comma 0. 0, comma 0. Got my 3 x-intercepts. All right, so let's graph some points. We need to go to our graph and press Control T to get some table values, right? Now, let's graph the ones that we can that are not too big. So, negative 12 is on here, that's fine. So, all right, let's do negative 5, comma 0. Plot negative 5, 0. Do it now. Negative 5, 0. It's already there. Negative 4, negative 12. Negative 4, negative 12. And let's do negative 3, negative 12. Is everyone plotting this? Because it looks like you're not. Faster. Then negative 2, negative 6. Negative 1, 0. 0, 0. Negative 1, negative 12. 1, 12, sorry. 1, negative 12. All right, so take a look at these points and plot these points real quick. Yeah. After this. Okay. Now, does everyone see this right here? I want you to sketch this as best as you can. What? Just graph it the best you can through those points. So let me show you how it's done. Ready? It starts at the top. It's going, let's not do that. Let's do this. So it's going down through that point, makes a little turn, up through this point, makes a little turn, down through this point, down through this point. Beautiful. So again, you plot the points, you do your best graph through those points. Now, does everyone see the words, oh, by the way, domain and range. Let's do that real quick. What's always domain and range? Negative infinity to positive infinity, negative infinity to positive infinity. And then one last little part. Local min, local max. Okay? Now, does everyone see right here? This is a max, but we call it a local max because it's not the top of the whole thing. It's just part of. It's just one little maximum along the way, and then we have one little minimum along the way as well. Okay. Now, how do we get anything on the graph? Looking at this right here, what do I press? Menu 5, 1. So if I go to the left till I get to the word maximum, now I have my maximum. Negative 0.472. Now I'm going to write that for maximum. Negative 0.472, comma, 1.13. Does everyone know how I'm getting these points? Graph it, Control T. No? Okay. Graph it, Control T, move it around, you can get these exact points. Don't fall down. Now let's get the minimum down here. So all I got to do is go to the left, 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 all the way down. And there we go, negative 3.53. That's a point, that's a negative, comma, negative 13.1. This is right there, and then this is right there. Okay. So, you should be able to do the assignment on this. It's like the notes examples. The one thing I will say, on 1 through 4, there's not a graph on there. You can just sketch it by hand, whatever you see on your calculator, do your best, okay?